Welcome to our video. We are the Georgia Tech Carrot Doggers team comprised of team members Andrew, Megan, Martha, Shishir, Bhavaya, and Andy. Our sponsor, Carrot Dog Atlanta, is located at 828 Ralph McGill Boulevard on the Atlanta Beltline. It was founded by Kemi Bennings, who had created a concept to sell delicious vegan carrot hot dogs. But now, Kemi is looking for some help. The problem statement scope is defined as such by Carrot Dog Atlanta. It asks for an automated tabletop machine to peel carrots. Breaking it down further, the scope can be separated to three distinct categories of engagement: peel, shape, and size. The peeling stage is responsible for peeling the carrot and separating the dirty outside layer from the clean inner layers. The shaping stage is responsible for forming the carrot into a hot dog-like shape. The sizing stage is responsible for cutting the peeled carrot down a size. The design process timeline outlined here is divided into several stages, beginning at Stage 1, Prior Art and Patents. Before concept generation even began, the team took a look into what was in the market and invented already. We found products such as the electric peeler, the Tellier manual carrot peeler, and the Tenrit Solo C machine. However, all of these devices were either too slow, too manual, or too expensive to be viable solutions. Next up, the team looked into any patents to gain insight into what's already been thought of, such as the original potato peeler, the automatic vegetable peeler, and the vegetable shaper.
After researching all this, the team proceeded into Stage 2, Concept Generation Drawings. Each team member produced an entire concept from start to finish to allow for everyone's input. The tabletop track peeler features a cart carrying the carrot through a set of sequential peelers. The discarded peels fall into the bottom tray and the finished carrot comes out of the machine. The lathe-based cutter features a claw rotating the carrot around and a lathe blade translating across the length of the carrot in order to cut it. Additionally, it features a table at the bottom to collect and separate all different carrot peels and the finished carrot itself. The carrot sharpener features rotating blades around the circumference of the carrot to peel it like a pencil sharpener. The automatic vertical peeler features sets of rollers that feeds the carrot through sharp shaping blades downwards to obtain the final peeled and shaped carrot. The semi-automatic lathe peeler is similar to the lathe-based cutter from before, except it opts for a manual crankshaft rather than an automatic spinning claw. The hopper-based rotational cutter features a hopper gate to automatically feed the carrots into the cutting zone, where the standard curved blades translate across the length of the carrot to peel it.
The next stage is concept consolidation, whereby the team evaluated each concept and selected the best ideas to move forward with. Starting off, the rectangular box enclosure was selected due to its ease of manufacture and simple geometry. It both holds and protects the interior components from the environment. Next, the team selected a lathe blade to be the shaping tool due to its known ability to shape cylindrical objects well. The shaping tool is set to a specific diameter that the carrot will conform to. The carrot holder was selected as the loading mechanism due to a large holding capacity and ease of access. With this, the team can automatically load carrots into the hopper one at a time. Moving along, the grabber was chosen due to its synergy with the shaping tool. The grabber securely holds onto the carrot and spins at an RPM high enough for the shaping tool to cut through. Next, the peeling tool was selected because of its widespread common use, which makes for lower manufacturing costs. The peeling tool can follow the contour lines of each carrot due to its flexible design. Finally, the shaving separation table was selected because of its ability to separate dirty peels in one direction, clean peels in another, and the finished carrot in a third. Next stage is standards and analysis, where we begin with food safety standards. Various government organizations and industry regulators have produced long detailed lists of standards on topics such as material selection and sanitation that must be adhered to. Next is material selection analysis. The requirements for our materials on the bottom left-hand corner, we must first begin with yield strength versus Young's modulus chart. Next, we sort our remaining materials by cost and see that the stainless steel family is the lowest price. This leads the team to select 316 stainless steel. Next, we show the fatigue calculations on the shaping tool. As a result of our calculations, the team finds that 316 stainless steel has a factor of safety of 25.03, which means that it's more than sufficient to safely cut the carrot for a long time. Finally, the team assembled a contact force testing rig to test the forces the carrot exerts on the shaping tool. It's discovered that the average force is 2.2 newtons with a maximum force of 8.8 newtons. At 2 inches per second, the motor and lead screw can output 12.06 newtons of thrust. Therefore, the team can proceed with the prototype. The next stage in the design process is prototyping. Here, the team is able to test how one subcomponent interacts with another subcomponent, such as how the grabber fits in the enclosure. And we can also see how the prototype develops over time through iteration, such as the shaping tool's 4 different designs. Now, let's jump right into the Tier 1 subassembly. Shishir, take it away.
So this is the carrot dogger, our prototype of the mechanism to be able to shave the carrots down to shape for Carrot Dog ATL. In this mechanism, we basically have a self-contained system that's able to hold onto the carrots with a grabber, shave the carrots down to size with a tool, a cutting tool that's similar to a lathe, and move the carrot from end to end, or move the tool from end to end using the lead screw mechanism. Each of these mechanisms are going to be covered in further detail.
So in order to keep the system contained and add safety for the user, we have this frame made of 80-20 aluminum extrusion with these polycarb sheets on every side. So if a carrot were to fly out or a piece of peel were to fly out, there would be no danger to the user. In addition, we have, in order to move the lathe tool back and forth, we have a lead screw. These covers are for food safety. They're just neoprene rubber, but it's powered by a motor over here. So the lead screw spins, and as the lead screw spins, this tool moves along the carrot. In the final design, there will be two separate parallel lead screws, one with a lathe tool and the other with a peeler. That would be able to peel the dirty layer of the peels.
In order to hold and spin the carrot, we have this rotating grabber mechanism. This mechanism clamps on the carrot and rotates on this motor to be able to provide a lathe-esque mechanism to spin the carrot while the tool moves from end to end. The result of all of these separate mechanisms is that the grabber will grab and rotate the carrot while the lead screw moves from end to end. After this is done, the grabber will release the carrot into a receptacle down below.